This is part 5 and the last part of the chapter 5 lecture notes. I wanted to come back to this slide. This is slide number 30, just because I wanted to make sure you had a correct definition for electrogenic. Um, Hopefully some of you took the time to look up the definition after the last, after part 4. But electrogenic just simply means that this is a type of pump that produces electrical activity in living tissue. Produces electrical activity in living tissue. And the sodium potassium pump definitely does that. Now, we had begun discussing bulk transport. Bulk transport, remember, is the transport of a large or a bulk amount of material across the plasma membrane. If the bulk transport brings material into the cell, it's called endocytosis. And if it exports or secretes the bulk material, it's called exocytosis. And there are 3 types of endocytosis. There is phagocytosis. And we have white blood cells called phagocytes. Phagocytosis is, cyto means cell and phagophage means eating. So it's a lot of times is referred to as cell eating in general biology classes. What it really is the cell is bringing or importing in some solid material. It could be food particles, it could be a white blood cell engulfing a bacterial cell, but the cell is engulfing solid material. Pinocytosis is when the cell brings in some type of solution, so it's often called cell drinking. And then there is a specific type of endocytosis called receptor-mediated endocytosis, where the material that's brought in has to bind to receptors on the plasma membrane before it can be imported into the cell. So it is a specific type of import. In phagocytosis, or cell eating, the cell membrane surrounds a particle and engulfs it. And if you would like to watch this YouTube video explaining that or showing you that, this is slide 34. Pinocytosis, or cellular drinking, the cell membrane invaginates. That means it forms an indentation. If this is your cell, for example, to show you what invaginate looks like. If you think about the way that word sounds, it's like the cell is forming a vagina. That's what invaginate means. And that it will surround a small volume of fluid. So your fluid would be in here, in this area. Sorry, I'm making it messy. And then it will pinch off. So the final product will kind of look like that. And the plasma membrane will actually pinch off, and inside of that plasma membrane will be your solution that the cell is engulfing. And receptor-mediated endocytosis is specific. The specific substance has to bind to receptors in order to come in. And this is a much better phagocytosis. This looks like a typical bacterial cell, but it's a large solid particle which is being engulfed. The plasma membrane is forming an invagination, and then it's going to pinch off. And that vacuole that forms from the plasma membrane is going to be enclosing that bacterial cell or that food particle or some solid substance. And in pinocytosis, a solution is going to be engulfed. That's why it's called cell drinking, but it's very similar. And in receptor-mediated endocytosis, this happens with certain types of cholesterol molecules, the ones called LDLs, or low density lipoproteins. I'll tell you a story. I had a blood panel run the other day at the doctor's office, and my LDLs were high, and everything else was great. And I had forgotten LDLs come from saturated fats and trans fats. And I had forgotten that I had put a little teaspoon of coconut oil in my coffee that morning. So they were doing the test immediately after I drank my coffee with my coconut oil. And coconut oil, even though it comes from a plant, actually is saturated fat. If you've ever seen coconut oil, it's solid at room temperature. So I realized that my LDLs were not really high. It was just where I had had that coconut oil. Anyway, so LDLs are the bad cholesterol. HDLs, or high density lipoproteins, are the good cholesterol. So a lot of times when they measure your cholesterol levels, they measure levels of LDLs and levels of HDLs. They want your HDL levels to be higher than your LDL levels, and they want your LDL levels to be as low as possible. So let's say the stars are the LDL cholesterol molecules, and they have to bind. This is such a bad example because usually they'll do an example where it fits into that shape, like whatever the particle is, fits into the shape of the receptor. But no, they drew stars and they don't look like they fit at all. But the concept is that the targeted substance that's going to be engulfed binds to these receptors, and then the plasma membrane pinches off with the target bound to those receptors. And this vesicle is now a coated vesicle, coated with receptors that contain your target substance. Now, exocytosis is exactly opposite. So whatever is in the vacuole, this vacuole probably formed by pinching off from the Golgi apparatus, and it's probably got some substance that this cell produced. If this is a cell from your pancreas, a beta cell from your pancreas, then these little blue molecules could be insulin. And so the vesicle or vacuole moves toward the plasma membrane, fuses with the plasma membrane, becomes part of the plasma membrane, and ejects or secretes its product outside of the cell so it can get to the rest of your body. Oh, and so that is it for the Chapter 5 lecture note.